In this demonstration, I'm going to walk through the crosstalk test. Crosstalk is feed through from one channel to another. So here we want to run one channel and see if we're getting anything read out of the other. There are two ways we can run it, with or without a chirp. So let me for a minute run it without a chirp, and let's start running. And so you can see better what it's doing. I have an oscilloscope connected up to the two channels. And so you can see the yellow is one channel and the blue is another one. And as we do this test, we're flipping back and forth between the two channels. So I have left in a loop back and I have right in a loop back. And this is how much of them is feeding through to the other channel. Let me just stop that. I've actually run this and saved it so we can look at one that was done earlier. But let me talk about using Chirp. Chirp is a faster way to run. And so in some ways it's really pretty nice, but it has a downside. So let's take this and move it here, and you can see what it's like to run a Chirp test. Let me just move this right off here, and let's run the Chirp test once. And that was it. And if you looked at the screen, you saw the chirp run in the left channel and then in the right channel. So compared with the other tests, there's not a lot of energy here. And the way to get this more accurate is to bump the voltage. So if I run this, for example, at 1/10 of a volt, we're going to get, notice, a much higher result, mainly because it's just hard to read the very, very small amounts of energy. If I run this at like 2 volts, let's bump that to 12, we're going to get actually a far more accurate representation, and by which we mean it's going to get closer and closer to the one that actually was done a step at a time, which is the most accurate. So by bumping the voltage and actually increasing the length to give us more data points, we will get a better chirp result. But no matter what you do, and let's give this a little bit of smoothing so it looks kind of flat. No matter what you do, this is not going to be as accurate as the much slower but more copious one frequency at a time. In any case, that's the crosstalk test. And here we can see we're at 140 dB down. And as the frequency goes up, we get a little more crosstalk. But this is, of course, in loopback is just beautiful. And that's the demo.